Hi, this is Mr. Max with Sankofa Mathematics. So today I'm going to do a question paper that I gave to the AS level students when I had a workshop with them, a 10-day workshop, where I covered quite a lot of topics. So the only topics that you won't see in this question paper is integration and vectors. But I am going to do work during the course of this week on the two topics so that we are done with theme one. So this question paper that I gave to them, you can also find a copy of such if you go to my Google Classroom. So the procedures are very simple. So you go onto your, obviously, Google, and you find all these 9 little dots here. So you look for the app, the Google Classroom app. It kind of looks like this, right? A yellow outframe green board. Now you will see that I've uploaded this very same question paper that I'm doing now onto my Google Classroom. Now you obviously will find the link of going to my grade 12 NSSCAS level. You'll find the link or the classroom code, that is this one here. All right, I'll include the code and also the invitation link on the description of the video below. You will see that under classwork I have posted the very same question paper that I am doing now. Okay, I'm just looking, so you will see here it's written June 2022 mock exam paper. So also you will see that I have the cover page as well as the question paper on itself. So you can obviously download it, or you can print it out for yourselves, and then you can surely work through it on your own, or you can print it out and then you see how I solve the questions and also the hints and a lot of pointers that I'm going to give through. Okay, so I gave this to my AS level students. They wrote this during the holidays, and I'm now working it out, putting it out there so that you can have more resources. So a lot of times people are also asking me on the channel, Mr. Max, can you also please make available paper 1 and paper 2? This is last year's papers. They are here. All right, so you just have to go on to my Google Classroom, and then you can just download them and you can print them out. Now this is paper 2, obviously. So you will also see that this one in the second term is when I'm going to work it out. So what I'll do on Friday or Monday or so is I am going to work out paper 1 of last year's paper, and I'm going to put it up also. All right, so you can download those things on my classroom. And then another thing also worth mentioning is that when you go to my YouTube channel, obviously hopefully by now everybody know how to subscribe, and then you click the notification bell so that every time when I upload a video, then you have that video, and I make them public in order for you to sort of download them, and then you can check them offline as well. All right, you can use this in your classes when you have smartboard technologies and stuff like that, or you can download them, watch them on your phone. All right, it's about assisting you out there. Now there are also a lot of questions people are asking me, and then you will see that I've probably covered that very same thing already. Okay, so you will have playlists, and under my playlist I still have to organize quite a lot of things, but you will see there are AS level videos, about 50 of them, examination revision questions. There is matrices for grade 11s, there is number operations, 11 videos, linear programming, quite a very sought after topic, coordinate geometry, or also known as Euclidean geometry, transformations, vectors, graphs of functions, grade 11s, shape and space. There's work for grade 8 and 9. Okay, I have about 26 question papers also that I've typed myself, and some of them I've worked out of past question papers. So there is basically work from grade 8 mathematics up until grade 12. Okay, so let's just go back to what I'm doing right now. So first of all, before I start with the question paper, obviously, that I gave to the students when I had the workshop with them. Take note, it's a 2-hour paper. That's how theme 1 will be. But there are certain instructions that I want to explain so that people can understand what is required when you are answering this paper. So first, they say the only additional material is a non-programmable calculator. I'm going to explain a bit later what that is. And then obviously geometrical instruments. Some of these things require you maybe to draw and then sketch, all right, things like that. So all working must be shown. This is very important, and that's one of the reasons why some calculators are not allowed. And you will see when I go to that, I have a soft or a presentation about that, so you can know which calculators are allowed and not. All right, and don't use things like correction fluids and highlighters and all those kind of stuff. And then for this purpose of this paper, you will see that on page 26 and 27, I have additional papers there, additional space when you need it. You go to those lined pages and then you can continue working like that. It's going to be more or less the same type of things in the examination. And another thing that you will also see attached to your examination question paper is a list of formula and notations that are provided within the scope of your syllabus, and it's attached there for your use. All right. Now, for the purpose of this very paper, I only took out the ones that are relevant, okay, to this paper 1. But there's a lot of other formula that you will be using. So it's also, you'll see, I'll refer to them when I solve problems. And then you may also use a non-programmable calculator. For pi, you either use a calculator value or 3.142. All right. This is the only option you are given unless you are told otherwise in the question. Now, if the degree of accuracy is not specified in the question, and if the answer is not exact, you're supposed to give the answer to 3 significant figures. That is your baseline. And you must give your answers, the ones that are in angle sizes, to 1 decimal place. All right. So one of the things also you need to understand, if you are talking about angle sizes, if you are dealing with radians, okay, for radians you must give them to 3 significant figures. All right. So this is the one that I've set up. You can use this template. You can print it out if you're a teacher and educator, and then you can just change things like, you know, the name of your school and the badge, and then you can give these to your students also to see how far they are. Now, I want to focus on this non-programmable calculator that you have here. And you will see in the emulator that I'm using, all right, I'm using a calculator, this 991ES Plus. It's an emulator that I'm using. So this calculator has got some functions in there, symbolic functions for integration and for differentiation. All right. So if you were to integrate something, for example, or differentiate something, for example, you can use this calculator. So it's not allowed because it has some of that function. One of the reasons that this calculator is also not allowed is because students are not showing their working. Okay, so if, say for example, you have to find the derivative of, let's say, differentiate, I can give you any function. So let me just write it here. So if I say to you, here's a function y equals to x to the power 4 plus 5x, and I want you to find the derivative of that. So that's dy dx would be 4x cubed. Remember that 4 comes in front, multiply whatever that coefficient is, and you reduce by 1. So that's 1 times 5, and that's going to be 5 and just 5. So this is the derivative function. Okay, so if I was to ask you, when x equals to, let's say, 4, what is the derivative going to be? So in this particular case, you would be saying 4, and then you have that 4 in there, cube, and plus 5. So you're going to substitute that into the derivative function. All right, so that is 64 times 4. Okay, let's just get our calculator back. So we get that value. So that's 4, open bracket, 4 cubed plus 5. Okay, so it gives us a whopping 261. All right, now in order for you to find this, supposedly you had to differentiate. So one has to see how you differentiate. Then you substitute that into the derived function in order for you to get that value. Now, if you are using an emulator or this type of calculator, this one here where I said it has this derivative function, okay, so you will say shift and then it's d by dx, which is an operator, and then you put in the function. So the function is x to the power 4, and in order for us to get that x, we press alpha and that x there raised to the 4th power, for example. Then you say plus 5 alpha x. Now it's going to ask you at x equals to what? And I've already determined x equals to 4. So I'm looking for that 261. Okay, you hit enter, you see you get 261. Now the calculator have basically you just input the function and then it differentiated for you, and then you got the value at x equal to a specific point. So now if you just write 261, and this is a 3-mark question, we have no way of seeing what working you have done. How did you justifiably get to that answer? So we need to be able to see the skills of whether you are able to differentiate and then apply that concept by substituting that particular value into that derived function. So these calculators are therefore not allowed. Okay, so I have as I said, a list that I took from the latest updated version of the the handbook that goes out to the centers of Namibia, where they are giving you information. They say calculator cases, instruction leaflets, or instructions and formula printed on the lid or cover of a calculator or similar materials must not be in the possession of a learner during the examination or a candidate. Learners can use programmable calculators. However, calculators with any of the following facilities are prohibited unless stated otherwise in the syllabus. So graphic display, graphic calculators is ones that you can see how the graphs are. Data banks, dictionaries, language translators, retrieval or manipulation of text or formula. QWERTY keybox, I'm going to explain that one now. Built-in symbolic differentiation or integration, this is what I was referring to. Okay, capability of remote communication with other machines. Any use of such calculators is a malpractice and you are going to be disqualified. Now, what is in the Namibian market? You will see this is an older version, all right, but and this is like a sort of a newer version in terms of how it is second edition. You can see that. So you'll see these quite a lot. These are also what you are not supposed to use. Ne? So they are not allowed. You're not supposed to use them because they have got those symbolic integration and differentiation things built into them, and therefore you can't just use them. All right, so what is it that what is a QWERTY keyboard? Now obviously the meaning of that are these things that have got typewriter like keyboards. Now people are asking me, what does it mean? Basically, you know, some things they require electrical outlets, make noises, use paper that are not permitted. All of these type of things you cannot use. All right, you probably have seen such type of calculators, so they are not allowed in the examination room. So what is therefore used? Well, you probably have this one. I call it the Kamagochi. Okay, this is the older version. Yeah, fine. Okay. Um, yeah, it only has A, B up to a certain, doesn't have all the alphabets, but this is a non-programmable. Similar with this one, this is like a latest one, an upgrade of this Casio, or you probably have seen the different colors like pink. So this is also an acceptable one, all right, or probably this old grayish one. So these are the calculators that I expect or we expect you to carry into the examination room. So do not use any of the other calculators you have. Because they are similar, um, you know, uh, functions does not mean you just say but this calculator and that calculator are identical. They're not identical. This one has an added advantage. That's why it costs you quite more than the others. All right, but for the purposes of my lessons I'm using that so that I can explain more in detail, and it's the emulator that I'm using in all of my videos. All right, so I hope that that at least clarifies everything as far as this calculator concept is concerned. Now I know that, for example, in my school, the kids, I've been introducing them and explain and showing them how to use so many functions on this calculator. And of course, they don't like it, but it's not allowed. The rules have changed. All right, so I hope that at least you don't make the mistakes of carrying material into the exam that are not allowed. Not a lot of things out there. The list is non-exhaustive. There are pens that scan so many things. People, we know about them. Okay, so don't get caught with this type of behavior. I know we say that cheating is a human phenomenon, but when the instructions are clear, you're not supposed to carry these things, do not carry those things. Okay, so that is why I have the cover letter here, or the cover page, so that I can explain concepts, and also to teachers, if you are setting up your papers, whether it's internal, try to follow the same guidelines as per syllabus. All right, so I already showed you how to find or download this paper, and you will see the link below in the video of this paper. It's going to be quite cumbersome and long. All right, so obviously you have the advantage of pausing it and playing it again. I'm not going to play it in stages. I'm just going to play the whole recording as it is. All right, so very first question, you have got find the first three terms in the expansion in ascending powers of x. Now, this is not a very difficult, concept if you were doing binomial theorem, all right? But you can go ahead and maybe say, okay, wait, what does it mean? So the first term we know is like 5 choose 0. So I'm going to just write it in vector form, all right? That is 1 to the power of 5 x raised to the power of 0, okay? That is obviously the one that I have here, and that is the x that I have here. The second term will be 5 choose 1, and then this is 1 to the power 4, and then x raised to the power of 1. Okay, so obviously you should remember that this power here and this one here sort of they correlate, okay, correspond. And then the third term would be 5 choose 2. That's the third term, so 1 cubed and then x raised to the power of 2, and so on and so on. Well, we just want the first three terms, so this is the first term. All right, so that's the first term, and this is still represented by the second term, and this would be represented by the third term. So you can calculate it actually. If you do 5 choose 0, that's going to be 1, and this one here will be 5x when you calculate it. Obviously, I hope you still remember how to do 5 choose 1. All right, you can obviously then x raised to the power 1 is just going to be that. 1 to the power 4 is just 1. 1 times that is just going to be x. And then next one here is 10. 5 choose 2 is 10. And then obviously x squared, and so on and so on. So if you don't know how to find, because remember 5, you press shift, you go to your division button, you see NCR, so if I choose 2, for example, you see the answer is 10, and that's how you find those coefficients. All right, so this is all that you needed to do in this particular question. So the second one, similar, you just have a different expansion to do, but here we also want you to find the first three terms. All right, so the first term 6 choose 0, I'm going to write it in vector form. Okay, so 1 raised to the power of 6, and then the minus 2x. So I'm going to put the minus 2x in bracket. It's going to be raised to the power of 0. The second term is 6 choose 1, so that's going to be 1 raised to the power of 5, and then the minus 2x is now going to be raised to the power of 1. And the third term will be 6 choose 2, and that is going to be 1 raised to the power of 4, and then negative 2x raised to the power of 2, and so on and so on. Well, you can go ahead, you'll see that it's going to be 1, that's the first term, minus 12x plus 60x squared, and so on and so on. All right, so again, how do you find the minus 12? Right, so 6 choose 1. If you have to use a calculator, you say 6 choose 1, well, you get an answer of 6, and that 6, if you now multiply that 6 with minus 2 there, can you see that? All right, that's going to give you the minus 12 that is there. Obviously, multiplying anything by 1 raised to the power 5 or any 1 there is just going to give you that same value. So 6 choose 2, so if I go back, so you can see 6 to you get 15. So that's 15 there, but that 15 now must multiply with a 4. Where's that 4 coming from? It's negative 2 all squared. So negative 2 times negative 2 is 4, and that 15 times 4 is where that 60 is coming from, for example. Okay, so this is 2 marks for that. kind of a little bit more work, and obviously the signs will oscillate, or alternate signs will be there. That means a minus, a plus, a minus, a plus, because the nature of what is in the bracket there. Okay, so now they're saying, hence find the coefficient of x squared in the expansion. So when we multiply, so we already have the first one, which was 1 plus 5x plus 10x squared. And the second one, oh my goodness, let me just make that a little bit nice. And the second one, perhaps if I can change, the second one was 1 minus 12x plus 60x squared, all right, and so on and so on. So basically, we are going to multiply. So now you're going to look for where are you going to get x squares. All right, so because we're looking for the coefficient of x squared. So if you multiply this one over here all the way with that one over there, that's going to give you 60x squared. Do you agree? And another one, if you multiply this 5x here with this 12x, that's going to give you a negative 60x squared. That's going to be squared. There's one more. If you take this 10x squared and you multiply it with this one here, you're going to get plus 10x squared. So in any case, if you now should simplify this, you're going to be left with 10x squared, because the 60x squared minus 60x squared will be 0. But what is the coefficient of x squared? So you will say, therefore, the coefficient of x squared is 10. Okay, and that is how you answer that particular question. All right. Now, let us go to question 2. Now, they're saying by using a suitable substitution, solve the equation. So how do you do that? All right, so you can say, okay, wait a minute. I'm going to say let the 2x minus 3, let that be represented by u. So what does that mean? So my equation is now u squared minus 4 over u, okay, squared, okay, because everything is squared there. Can you see that? Minus 3 should equal to 0. Of course, you can use any other letter. Now, from here on, it's just a matter of you simplifying this, all right? So what I will do is I want to clear the denominator by multiplying by the denominator in this term, as well as that term. Obviously, when you multiply on that side, it's just going to be 0. So we have got u to the 4th minus 4 minus 3u squared is equal to 0. Okay, basically I will just rearrange this, because this is like a hidden quadratic, if you are familiar with that word. So basically, when you are here, you can factorize. Okay, you definitely see that well, I'm going to have my two brackets here, numbers that multiply give you negative 4. So u square here, u square here, and that's a minus. One bracket should be a positive, one should be a negative. And the numbers would be 4 and positive 1. Now you can solve what the values of u are. So you will be saying, okay, wait a minute. So u square minus 4 should give you 0, because when you multiply two things give you 0, it implies one or the other is then 0. All right. So this is helping you to solve for u. All right. You will have a problem in this one here. This one here, it will be invalid, because the square root of a negative number will not exist. So we're just going to have u equals to positive or negative the square root of 4. Okay, that's what you do when you take the positive and the negative root. So the answer will be positive 2 or negative 2. But we're not looking for that. We're looking for 2x minus 3 will equal to 2, or 2x minus 3 will equal to negative 2. Remember, our u was 2x minus 3 there. Okay, so now we can actually solve for x, and if you solve for x, you should receive that x here would be nothing but, well, you can go step by step if you want me to. So that's going to be 3, x here will be 3 halves, or you're going to have 2. There we go again. So let's just slow down a bit. There we go again. So we're going to have 2x equals to positive 3, but then you are having a minus 2 here. Okay, so you're going to have in fact, let's come back to this one here. You carry over the 3 all right? Because you have to say, well, there was a 2, so you now have to add. So let me just add that 3 there, the same way like I'm going to add this 3. So this is going to be 5 halves. That's one solution. All right, so this is going to be x equals to 3 minus, that's a half. All right, so therefore the two solutions there, my two solutions will be of x would be 5 halves or 1 half. Okay, these are the solutions for this equation, and you can go ahead and you can substitute them into the original equation. You will see that it definitely gives you that 0. Good. Next question. So we have got the equation here. We're supposed to solve this equation. That's 4 marks. Okay. Maybe I'll also explain to you how the marks are, but you should be quite familiar with the basic trig functions by now. Okay. So what you can do first of all, you can multiply by that denominator. So you're going to have 10 theta plus 2 sin theta equals to 3 multiplied by 10 theta minus 2 sin theta. Okay, so I clear the denominator. That's what I'm doing over there. Okay, all right, so let's just multiply out. So that's 3 tan theta minus 6 sin theta, and this here is 10 theta plus 2 sin theta. Okay, so far so good. Now let's collect the like terms. So when you look at the like terms, you're gonna have perhaps I don't want to work with negatives, or I'm going to say, well, this is 3 tan theta minus 10 theta, and this is 2 sin theta plus 6 sine theta. Okay, so this is going to give me 2 tan theta, and this is going to be 8 sin theta. Okay, so far so good. So we have it like that. So now you can actually decide to solve. You should also be a bit aware of our restricted domain here when we are solving this equation. So I'm going to come back to that when I get to solve the questions here. All right, so I don't want a sin and a tan. So what I'll do is, I know that tangent is the same as 2 sin over cos theta. Okay, you should know that tan theta is nothing but sine theta over cos theta. You should know this fact, right? All right, so this is 8 sin theta. All right, so what is now that I'm going to do with this information? Well, perhaps I can move this around, maybe to explain the concept here. Maybe before I do that, just so that I can have some sort of, proper steps that I want to follow. So what I will do is, before I do that, I'm just going to rewrite and let it say 8 sin theta minus 2 tan theta is equal to 0. And then I'm going to have 8 sin theta, then minus 2 sin theta over cos theta. All right, let it equal to 0. Then it's easier for me to do that. All right, so what does it mean when you have equal to 0? Of course, remember, this is the same as it being over, it's over, let's see, so let's just have our pen back. All right, so this is the same as over 1. So what I'll do is I'll multiply this side by cos theta. I'll multiply here by cos theta. Okay, and I'll multiply here by cos theta. So I'll have 8 sin theta cos theta, all right, minus 2 sin theta equals to 0. I hope you are so far following what I'm doing. Now I can take out the common factor. The common factor is 2 sin theta, and it goes here. It's going to leave me with, 2 goes there, 4. Okay, minus, so obviously 4 cos theta. So let's just leave that. 4 cos theta minus 1 is equal to 0. Okay, right. So divide throughout by 2, or you can say 2 sin theta equals to 0. Well, I'm going to ignore sin theta equals to I'm going to ignore sin theta equals to 0. Okay, why is that? Let's look at our domain. Remember, our domain is from 0 to 180 degrees. Okay, so our domain is from 0 to 180. Okay, right. But now, what is sin theta equals to 0 equal to? I'll wait for you to tell me. So if you don't know, you use your calculator. You'll say, okay, make sure your calculator is in degree mode. So inverse sine of 0 gets 0. Okay, so 0 is not our solution. Okay, because our domain should be between 0 and 180. 0 is not included. Okay, can you see that? This is not included. It's between. So 0 is therefore not a solution. So we are not going to work with theta equals to 0 degrees. All right, it is not in the domain. Okay, it's not in the domain. It's not in the domain. I'm just going to write that in here. All right, so it's not in the domain. So that's why I'm going to ignore that. So what I'm going to work with is 4 cos theta minus 1 is equal to 0. So that means I've got cos theta equals to 1/4. I hope you can follow. Okay, right? And then we need to find what is the angle. And that angle would be, it's a acute basic angle. Cosine is positive in the first quadrant. Okay, but our answer should be between 0 and 180. So cosine is positive here. So our theta, angle theta will be here. And we'll not accept that one because if we do get, but in the second quadrant, cosine is negative. So there's only one solution here. So we'll go ahead and then find that angle. So you will be saying, when you need to find an angle, inverse cosine or cos arcta or arc cos of 1 over 4 or 0.25, you choose that one. Well, you get an angle of 75.5 degrees. All right, 75.5 degrees to 1 decimal place, 75.5 degrees. All right, so you can then go ahead and say, therefore, theta is equal to 75.5 degrees. Okay, so that takes care of that. So look at your domain very carefully so you understand. If there was an or equal sign here like that, I would also be considering 0 as an answer. But now it is not in the domain, so I'm not considering that answer that side. Okay, right. So that brings me to the next question. Again, if I'm moving too fast for you, then you have the advantage of pausing the video and also of rewinding, if you can still say it, rewind these days. In your textbook, if you are using y equals mx plus c, this is for the AS level learners in Namibia. There is a little note there, so you'll go to page 30. All right, that's where I need you to go, and then because when you answer this, it's also important that maybe you understand a few things. When a straight line, and here's the word intersect, okay, a curve at two distinct points. Very important. You should know that the discriminant is greater than 0. Because this is a very important concept, because this question requires to look at the discriminant. Okay, so first it says the line has an equation. So you have the equation of the line, y equals to 3x plus k. So we don't know where this line cuts the y-axis. And the curve has got the equation y equals to x squared plus kx plus 6, where k is a constant. Find the set of values. When you have a question that says set of values, you are dealing with an inequality. Okay, you're going to deal with inequality. That's what we have over there. Can you see that? All right, very important that you get it. All right, so you need to find the set of values for which the line and the curve have two distinct points. So first things first, the first thing you do is you equate these two. So you'll be saying x squared plus kx plus 6 is equal to 3x plus k. All right, because y equals to y equals to, so you equate them. And then you write it in standard form. So standard form is the form ax squared plus bx plus c equals to 0, where a is not equal to 0. So it's going to be x squared plus kx, and then you bring the other one, it's going to be minus 3x now. Okay, you follow? And then I have a plus 6, and then you bring that other constant over, so it's going to be minus k. All right, equals to 0. So we have to write it in that form. So eventually, I'm going to write it as x squared, and I'm going to have plus, in bracket, I have k minus 3x here. Can you see what I did there? Plus 6 minus k. I'm going to put that also in bracket. All right, so it's important that I do that so I can identify my values for b and c and a, the discriminant, because remember the discriminant is b squared minus 4ac. Are we okay so far? So that means then I would have b, which is k minus 3 all squared, minus 4 times the value of a, right, times the value of c, c being 6 minus k, equals to 0. Now, I'll come again to explain what is it I'm going to do here. I'm going to find two values of k, but what is it that I'm expecting? Okay, right, so if you multiply out this whole thing, you will eventually end up with k squared minus 2k minus 15 is equal to 0. That is if you how to clean that up and then sort of work it out, okay? So it's important that you change to an equation. It will assist you with quite a lot of things. So here's the thing that we are realizing from this equation. From this equation, you can see that if you were to draw this graph, the graph will be a parabola that opens up. Okay, so what I'm looking for here, these values of k, is when I am solving this quadratic equation, I'll have two values of k. K will equals to -3, or k will equals to 5. So what does those values mean? Well, those values are simply the -3 is here and the 5 is here. Okay, but because our discriminant, okay, is greater than 0, remember that, because our discriminant is greater than 0. So what does that mean? It means our solutions, the set of values, will be the values that are above the x-axis. Okay, so when you are solving quadratic inequalities, please go back and make sure that you understand that. So what are our solutions? It's either k is less than -3, okay, or k is greater than 5, not or equal to. That is the solution, the set of values of k that will satisfy these two things. So if you don't quite get the concept, okay, you can play around with some software and then you can see exactly what it means. So maybe I will do that only for the purpose of this video, for explanation. So our straight line, okay, so remember what I'm doing right now here has got, we're done answering the question. So let's say our straight line was y equals to 3x plus k. Our curve was y equals to x squared plus kx plus 6. So let's look for values of k that are greater than 6. So let's say if k equals to 7, okay, are these two graphs going to intersect? So I'm going to have y equals to 3x plus 7, and the other one is y squared is equal to x squared plus 7x plus 6. So I'm going to draw these on my software, and you will see that if you draw them, okay, the line will cut the curve at two places, okay, and the line is going to go in that direction because the gradient is positive. So let's just quickly do that quickly. So I'm looking for GeoGebra, which is also an application you can download. It's developed by some Danish guys, and it's quite free. You'll see me often using them in my videos. So I'm just going to quickly draw those two functions so you can have an idea. So the other one was a straight line. It was y equals to was it 3x plus 7, 3x plus 7. Okay, so that is the straight line. The other one was y equals to, it was a curve, x times x squared, then I said plus 7x, all right, plus 6. Can you see that if I just have to zoom, that the line is cutting the curve at two distinct places for values of x that are greater than 5. If you choose a value of x that is less than 5, okay, so let's suppose we say k now. Let's say we are going to make this value of k, let's suppose I'm choosing the value of k as a number that is less, so let's say less than 5, greater than 5. So let's say we make it a 4, right? So let's have a 4 here, and let's have a 4 there. And let's see what happens to this particular, okay, that one I'll still leave it as my k. Even what I was doing there was totally rubbish. All right, so let's have 3x plus 4 and that graph like that, and let's see. And you will see that they won't intersect. So if I go here, I said that becomes 4. And if I go here, that becomes 4. If I hit enter, can you see that the two will not intersect at all? Doesn't make a bit sense to you. So the graph, the straight line and the curve will not intersect. So therefore the solution there will not be possible if you were looking at k equals to 4. That is things that are less than 5, okay? It only works for things greater than 5. Not even 5 will work. Okay, I hope the concept is quite clear to you. Okay, I had to take a small break there. So I looked at the number of questions. So we have about 15 questions. So I might divide this video into 2 or 3 parts. Okay, so let's do one more question. Functions f and g are defined as follows, and this is very important. We're not just giving you unnecessary information in mathematics. Okay, function f is such that x map onto x squared plus 2x plus 3. This is a quadratic function. It's only defined for x is less than or equal to -1. Function g, which is a straight line function, is only defined for x is greater than or equal to -1. Okay, very important, that information that you understand. So the first thing they ask you, express f of x in that form. This is a vertex form, and by now it should not be a problem for you to do vertex form. So I don't know how which method you prefer, but let me just write function f of x like this, and let me say y equals to, well, I have x squared plus 2x plus 3, and then I have y minus 3, then I have x squared plus 2x. So what I do is I first move that constant over, and then I find half of the middle term. Okay, so half of that, half of 2, and squaring it. So what is very important is that when you multiply this x plus 1, okay, so it's always b over 2 squared, okay, of half of b squared. I hope you still remember that. If you multiply x minus 1 squared, you're going to get x squared minus 2x plus 1. So in hindsight, if you look at what I have here, there is a plus 1, but there's no plus 1 here. Okay, so there's a plus 1 in this thing if you were to multiply it out. So I will then cleverly say, okay, let me remove that 1 there as well. Okay, Right, since the coefficient here is just 1, there's nothing much that's going to happen. So I'm going to bring my constant term back. So this is going to be x plus 1 all squared minus 1 plus 3. At the end of the day, this leaves you with x plus 1 all squared plus 2. And this is 2 marks for doing that. Okay. Right, so the range is this particular value. Right, remember, what does it mean? This graph here, it's in vertex form. Okay, so what is this lowest point going to be? We refer to a parabola as something that has got a turning point. And the lowest value here, you have got an x value and a y value. And that y value is the lowest point of the graph. Since a is less than 0, as you can see in this case, the graph will open up like that. So it will have what we refer to as a minimum value. So the turning point, in fact, the turning point will be -1. It's opposite of whatever is in this bracket. And the y value will be 0.2, which is this value here. That's what the vertex form tells you. It gives you the transformation or the translation of the function. Okay? So it means that 2 units up from the x-axis, and then you're going one place to the left. Okay? Obviously, it will cut the x-axis at 3, or the y-axis at 3. So the range is going to be y is greater than or equal to 2. That is the range. That is where this particular graph, that's the lowest point of that graph. Okay, since I have the software, I'll just quickly also show you what I mean. So if I was to type that function in, so it's y, the function is y equals to, so I have x times x, it's x squared plus 2x plus 3. Can you see? Right. So the graph is 2 units up from the x-axis. The turning point of the graph, remember what I told you, the turning point of the graph is x is -1 and y is 2. It will cut at 3 there. So this graph does not intersect the x-axis, okay? So that is the lowest point, the minimum point. So it is then defined from this point all the way upwards there. But here's the thing that I want you to understand also. They say that the graph is only defined for x is less than or equal to -1, which means this part of the graph is not drawn. Do you understand this concept? Because it's only defined, if you go back to your paper, it's only defined for x is less than or equal to -1. So when you look at the graph, values of x that are less than or equal to -1 on this side. So this is the only part of the function that is drawn. I hope that concept makes you understand why this is so important. Okay. Something else though that because I'll come back to this point when I do part C of this particular question. All right. So let's not spend too much time there. We have the answer, so you get 1 mark for giving the range. We are not going to accept an answer. We do not allow an answer of x is greater than or equal to 2. That is totally rubbish. Okay. Now, let us go to the B part. It wants you to find the inverse of f. So, what is f? F of x is equal to x squared plus 2x plus 3. And we know that it is defined for x is less than or equal to -1. Right, very important. From our previous work, we wrote this as x plus 1 all squared plus 2. This is vertex form. So I'm going to say y here, the same thing. So here it's standard form, and here is vertex form. Why is vertex form important? Because when you have a quadratic that you need to find its inverse, you need to work with the vertex form. So you go ahead then, and you're going to swap around the x and the y. Okay, so that's x equals 2. Now you have y plus 1 all squared plus 2. So the objective is you must make y the subject of the formula. Okay, so in case it's going to be x minus 2 equals to y plus 1 all squared. So this is going to be, let me just rewrite it nicely as y plus 1 all squared equals to x minus 2. I'm going to put that in bracket because now I must take the square root of that stuff, x minus 2. But here's the thing. The square root of anything, the square root of 36 is positive or negative, right? Because negative 6, or if you square it, you're going to get that value there. Is that clear? But our particular solution, of course, let me finish making y the subject. So it's going to be y equals to, I'm leaving this out for now. I'm going to explain my point. Minus 1. Please make sure that minus 1 is outside the root. Of course, it's not y that we're looking for, but we're looking for the inverse of that, which is x minus 2 minus 1. So this would be you answering the question, but you are not done though. The inverse of the function. Now, here's what I want you to understand. Just go back to this. So this graph is only this particular part that has been drawn. Okay? So it means then, if you have your graph, its turning point here was negative 1 and it was 2, right? So it's only this part. So remember that's 2. So what we are swapping it around now, if I swap it around, whatever that coordinate point is, remember it's the point negative 1, 2. If I swap it around now for the inverse, so I'm going to deal with 2, negative 1. So that will be 2, for example, and negative 1 will be somewhere here. So that graph is going to go in this direction. Okay? So let's see, because what you should also know is that when you draw an identity line here, y equals to x, the two things should overlap. So if I was to draw the inverse of that graph here, the inverse of that graph is going to be y equals to, and I'm going to put a positive first. So that means positive, but remember, if I put it there or it's not there, remember it is actually there. So I'm going to take x minus 2, and I'm going to raise it to the power of a half. Power of a half is the same as taking the square root. Okay. And it was minus 1. So what I want you to understand also now, from what I've done there, is this here is the positive root. And the only particular part of the function which is defined for values of x that are less than or equal to negative 1, which is only that leg, basically, that's supposed to be drawn. But if I was to take the positive root here, this green part will not be superimposed if I draw a line here, y equals to x. So the root cannot be positive. So it has to be something else so that that black part, if I fold it over this line, can fit nicely on the green part. And that is only going to happen if I have a negative value there. That means it goes the other way around. So only now it's going to work. Do you follow what I mean? Because if you draw the line y equals to x, that line there, this line is the identity line. So if you were to fold, only now will it fold nicely. And also, you could choose any other point on that graph and you put it here, for example. You swap those points, you will realize that it has to go in that direction. So it is the negative one that you're going to choose, okay? Not the positive one. So we will allow in the examination for if you make allow one sign error. So if you put a positive, or I can say it's positive, you will get, one sign error, which means we'll allow that. But the correct one should be a negative here. Okay, in order for that to be to justify the domain that you had there. Okay, I hope you have done so much work on functions for you to understand this particular concept. When you look at part C, now we're taking G, and if you remember, G happens to be a straight line, so I'm just going to write my G, just find what my G was. Function G is 2x plus 1, and it is also defined from very specific values. So it was 2x plus 1. I'm just going to write it in here. G of x is equal to 2x plus 1. And f of x was x squared plus 2x plus 3. And let's just quickly see f is x should be greater than or less than or equal to -1. That's how it's defined. And g was greater than, if you go back to the original definition or domain which that function was defined for. So what they are now saying, we are supposed to take these two functions, composite functions, and we should let it equal to 13. That means you're going to take function f, this whole function f, this one here, this whole function f. Can you see that? This will always go from the back. And you are going to substitute it everywhere we have an x in the other function. So that means 2, open bracket, okay, equals to 13. So this is basically what you need to do. So x squared plus 2x plus 3. That's how you do this one. Now you can sort of clean it up. So it's 2x squared plus 4x plus 6 plus 1 equals to 13. So it's 2x squared plus 4x. That's 7. If you take away the 13, is going to be minus 6 is equal to 0. Okay, now you can actually simplify this further by dividing throughout by 2. So that's going to give you x squared plus 2x minus 3 equals to 0. 2 goes into 0 0 times, and so on and so on. And this actually is something that can be solved. It's going to be x plus 3 and x minus 1 equals to 0. So the solutions are x equals to -3 or x equals to 1. But here's the thing. The function f is only defined for values of x that are less than or equal to -1. So a solution of 1 won't work. What does it mean? If you look at that graph, that one there, okay, so let me just uncheck this one and also the inverse. Right, it's only this part that is there. You should not see the other part, okay? The way I draw it, I can't restrict it with this formula, with this software now, okay? So if I was to draw the line, y equals to 2x plus 1. And I'll ask you, well, not like 2x plus 1, where you sort of take that function and you let them equal to each other. The solution will only be one value, okay? Only be one value, because I have two answers. I have x equals to -3, so -3 will be somewhere there. But x equals to 1 will be on this side, and that particular part of that graph is not there. Can you see that? Because your graph is only defined from this part going up to that part, positive infinity. I hope you get that concept. So what does it mean then? It means that x equals to -3 is the only answer. Very important that you understand. Okay, so there's a lot of work on functions that you need to understand, but also be very careful when you are given restrictions on your domain for which the particular functions are defined for, in order for you to answer those questions. These things are not just given to you, for free. They mean you are supposed to use them in order for you to get to solve these questions accordingly. Okay, right. So this is where I'll end part 1 of this video, and then I'll start with part 2 doing question 6, where we're now starting with APs and GPs and the works.